All right, so this was your classwork problem from before, right? So you should have already completed this. This is 4.4.5. And so we're going to move on to the last topic. All right, so we're going to talk about learning the implications of the factor theorem. So let's talk about the factor theorem. And a lot of times with math, you get these lots of letters and weird-looking symbols, but when they're explained properly, when you understand them, it's really quite simple. So there's a little bit of a shock factor sometimes in looking at these theorems, but ultimately at some level, once you understand, take a moment to understand, they're not so challenging, really. So let's take a look at the factor theorem and talk about what it means. So the factor theorem says a polynomial has a linear factor. We talked about linear factors before. If and only if f of k, so k is this value here. Remember, we used that value of k that made x minus k, that factor, equal to 0. If and only if f of k is 0. And that's what we learned with synthetic division, right? We used x minus 2. We used 2 as the value for synthetic division. And then we solved to see what we got using the synthetic division process. All right, so let's use the factor theorem. We've already briefly talked about it to determine whether x minus 2 is a factor of x squared plus 2x minus 4. And so we're going to use 2, right, as our linear factor in the synthetic division system. We're going to use the coefficients for x squared, 2x, and minus 4. So 1, 2, minus 4. So I'm going to drop the 1 down, multiply by 2. 2 plus 2 is 4. 2 times 4 is 8. 8 plus minus 4 is 4. All right, so we end up with 4 as the remainder. So we get a quotient of x plus 4 with a remainder of 4 over x minus 2 from the synthetic division process. And what this says is that f of k is not equal to 0. So if f of k were equal to 0, then this value here would be 0. All right, so let's use direct substitution now in the same process, and let's see what we get. So direct substitution now, we would take that linear value in the linear factor for synthetic division, and then we're going to substitute it into this quadratic, and let's see what we get. So x minus 2 then leads to x is equal to 2, and we're going to substitute 2 into the quadratic. 2 right here, 2 squared plus 2 times 2 minus 4 ends up being equal to 4. And so what this says is the point 2, 4 is part of the polynomial. And it also says that x minus 2 is not a linear factor. So we can get those two things from this. But you see here that 4 is the last value, is the same as the last value here when we find the quotient. It's really the remainder value. But this remainder value is also alongside of 2. This is the y part of the coordinate for a value that's on the graph of this polynomial. All right, so we use direct substitution. We end up with 4. Direct substitution is a little bit simpler, and it's really related to the factor theorem directly. But we can use direct substitution or synthetic division in order to find out whether or not f of k is equal to 0. Either this value is 0 at the end when you substitute 2 in. Remember, it could be any value, whatever value in a linear factor that makes that binomial equal to 0. Or when you use synthetic division, this value here ends up being equal to 0. Right? Then we know that we have a linear factor x minus k. All right. Okay, so we're going to use synthetic division. So this is practice now again for you. So use synthetic division and see if x plus 5 is a factor of this polynomial. It's already written in standard form. Please note there's an empty term here in x. So please be careful of that when you're using synthetic division. Let's see if you can work it out on your own. I'm going to pause here. Okay, so I've got x plus 5. So my synthetic division factor is going to be minus 5, the value of x that makes this binomial equal to 0. And I'm going to set up my system, making sure to leave that placeholder for 0. So I have 3, 15, negative 1, 0, and 25. I'm going to drop this 3 down, multiply by negative 5, negative 15, add together 0. Negative 5 times 0 is 0, negative 1, is -5. -5 times -1 is 5. 0 plus 5 is 5. Times -5 is -25. And as we go through the system, we do end up with 0 as the end. So minus 5 is going to be, or x plus 5 is going to be a linear factor of the polynomial 3x to the fourth plus 15x cubed minus x squared plus 25. And you can see that we drop these down in order. This is the last number here is a remainder, it's 0. And then we can find the quotient just by dropping down constant value for x, x squared, and x cubed. I have the coefficients using synthetic division. All right, so now we're going to use direct substitution. I can already tell you when we substitute -5 in, we're going to get 0 out the other side. So as a result. So let's see if you can take care of this on your own. And I'm going to give you the answer. So please pause here and work this out on your own. All right, so I'm going to substitute -5 in, right? And I go through the process. I get 0 out. That's what we expected because it's the same result that we get from the remainder. We had the same linear factor, the same polynomial we used for synthetic division. We're getting the same result here as 0. So we should see the same result in direct substitution. Direct substitution is generally a little bit easier. Right? We don't have to set up a system. We're just substituting the value in to determine if x minus k is a linear factor. So it is in fact a linear factor because x is equal to 0 is the end of the result. Or f of x is equal to 0. Okay, so this brings us to 4.4.5, I believe. Right, so this is actually 4.4.6, or a 6th classwork problem. And here we go. All right, so I need for you to copy this down. You can choose either use direct substitution or synthetic division to determine if x minus 4 is a linear factor. Right, if we use direct substitution, you have to figure out that value of x that makes this, and also for synthetic division, that makes this value equal to 0. Substitute that in and let's see what you get. And then make a statement about whether x minus 4 is or is not a linear factor. Right, that brings us to the end of our discussion on factoring polynomials. Thanks for joining. Lots of stuff. You may have to go back and listen to this a couple more times. But really important for factoring and understanding how to manipulate and simplify polynomials. Thanks for joining. Talk to you soon.